Okay, this is going to be a little tutorial video on a feature of the Cartesian display that I've never talked about before. Do you remember a while back I did this video about the turbocharger, and it had this flange, and it was a really difficult setup, and it was all I could do to get the setup such that this flange was, lying exactly in the XY plane, parallel to the bed of the machine, and I had to free myself from the constraints of the orientation of these holes, and these holes were the features that I needed to remachine. And so I needed to just allow the flange to kind of go where it wanted, bolt it down, and then we built out some geometry based on some existing features of this flange in order to complete the machining. Well, this is going to be a similar situation, except we have a round flange, and it's going to be a similar case where I don't have a real-life example. That's why I'm using the paper dolls here. Suppose that we have a case here. We have this round flange, and it's all we can do to get this thing mounted on the machine, and this thing is parallel in the XY plane. So we need to ignore the timing of this pattern of holes, right? We need to free ourselves from that constraint and just let them go where they want and get the thing mounted up on the machine any way we can. And now what we're going to do is we're going to use a feature of the Cartesian display to make the part model match what's physically on the machine, okay? Okay, so you can see that I've got the part captured in CAD, and that allowed me to import it into the CD client software such that I could upload it into the Cartesian display. Okay, so here's the part model. It's all loaded into the display and we're ready to go. Okay, so suppose this is our setup, and we only really know two things about it. We can figure out the center of this pattern, right? We can indicate the part somehow and find the center. And we have, say, one good hole, this one here. Alright, so what can we do? I'm just going to be using this pointer here in order to illustrate what I'm doing here. So the first thing we would need to do is indicate the part somehow to find the center of this pattern here. Okay, so we would indicate that hole and get that exactly on center. Next, once we've found the center of the hole pattern, we zero out the DRO, X0, Y0. Next, we zero out the Cartesian display. Menu, System, Set XY0. Now we got 0, 0. Okay, so the feature that I want to show is on the menu here, the draw function, draw. So we go into that, draw. Okay, so it's asking for a point. Locate first point, hit OK. So to define a line, you need 2 points. So what you do is you move the machine around, indicate a hole, pick up a corner, whatever you got to do, and you hit OK, and it will latch the position of the machine at that location and define a point there. Okay, so I'm going to hit OK. Then it says locate second point and hit OK. So let's say we have to move the machine around, and maybe we indicate some hole or pick up an edge or whatever we got to do. That's where we want to be. That's where that line segment's going to end. So we hit OK. Okay, and so it defined that line. See how it's turned red? That means it's immediately on radar, and it named it line 19. So this is an official line in the user geometry database. So now you might remember that anytime an entity is in red on radar, you can hit the OK button and it will tell you everything about it. Right? In this case, it's a point. It's a line between 2 points from this XY to this XY. The reference angle is 42.675 degrees. Reference angle is the angle that a line makes with the x-axis, and it gives you the equation of the line in slope-intercept form and the length of the line segment. And I debated on whether to call this the draw feature or the measure feature, because it allows you to use the machine to measure things. But I settled on draw. So, and we have indeed, we've drawn that line, okay? And we've drawn line 19. Alright, now you can almost imagine what I'm about to do next. I'm going to move our pointer back to 0, 0. Then I'm going to go into the draw function, menu, draw, locate first point, hit OK. We're at the first point, OK. Now I'm going to move the machine. In our case, I'll be moving an indicator out to this hole, all right, and then we're going to indicate that hole in exactly the way we want it. and that's going to be our second point, and we're going to hit OK. So imagine I've got that hole trammed in, it's just right. Now I'm going to hit OK for the second point. All right, now let's look at what we've done. So we've defined line 19, which went from 0, 0 out to this location where the hole was. So the spindle's sitting right here, and we've just indicated in that hole, the one good hole on this pattern. Now, you'll notice, of course, that it's red. It's on radar, so we can hit the OK button, and we can learn everything about that line we want to know. Right? So remember, it started at 0, 0, and now this is the location where the spindle is right now, right over that hole. This is the reference angle that line makes with the x-axis. And the length of the line, of course, in this case, it's going to be the radius of the pattern, which happens to be 2.61 inches. All right. Now, the reference angle, this is what we're after. So I'm just going to write that down, 42.772 degrees. Okay, so what I'm going to do now is exit out of here. I'm going to go to Menu, Rotate Part. So it says Enter Angle. So that 42.772 degrees, that's the angle that this line makes with the x-axis. I'm going to rotate this part geometry counterclockwise so that this little hole winds up exactly where the spindle is. And I can only do that by rotating it that number of degrees, okay? So I'm going to go 42.772 and, 772. And that's going to be negative, right? Negative is counterclockwise, okay? Hit OK. So now you can see that all the part geometry has moved, and so now what you have is our part model now matches physically what's on the machine, okay? So we're right over that hole. We've moved the geometry to match where the spindle is, the correct number of degrees, and now all these other holes, they're exactly where they need to be in order to machine them. Okay, so when it defined this line, line 19, remember that's in user geometry. That's why it's in purple. We need to get to part radar mode. So part radar is going to give us our radar distancing to entities in the part model. User radar is only going to show us radar distances to user geometry. Okay, so we want to toggle into part radar mode, right? And we need to go to radar mode, and we need to pick holes. Okay, so we're in part model holes. So now we need to we would either use our roadmap, or in a tiny model like this we can just hunt for it. So I'm just going to say next, next, next. There it is. So circle 4, that's in radar now. Now I can navigate the machine over to that location. Okay. And I'm going to use the delta X and delta Y to focus the spindle exactly over that hole location. Okay. Right there. Now this has got to go positive a little bit. Close enough. Okay, so now we're exactly over that hole, and now we can machine it. And as you can see, we are indeed exactly at that location. Now, one thing I want to point out is, remember when we rotated the part geometry, that 42.772 degrees, did you notice that line 19, it stayed put? Okay, so let's do it again. Let's go to Menu, Rotate Part, 42.772 degrees negative, right? So I hit OK. So now the part geometry all moved, right? Well, line 19 didn't move, right? It stayed put. And the reason why it stayed put is because, I'll show you in a second. Let me put it back where it was. Cancel rotation. All right, so in modes, there's an item you can select called Rotate, Translate, User. So I have it unchecked. That means when I do a part rotation, it's going to ignore the user geometry. It's going to leave the user geometry alone. Okay, if I had it set, which is actually the default, okay, and then I went into rotate part, and then I said 42.772 negative. Now you see our line 19, that rotated with it, okay? And That's not always useful, it's not always what you want, but maybe in some cases it is. So I'm just trying to explain as to why line 19 didn't rotate with the part geometry. You can select whether it rotates or not. Okay, thanks for watching.